Okay, let's just dive right into this explainer and, demystify what is arguably the most complex system humanity has ever built, the internet. I mean, we all use it every single day, right? But if you pause and really think about the sheer magnitude of what makes it all work behind the scenes, it's absolutely wild. It's a fascinating feat of engineering. So today, we're going to break down this incredible network of networks.
We hear about saving data to the cloud, literally all the time. It's just baked into our everyday vocabulary now. But I really want to start by asking you kind of a fundamental question. Where does that information actually live? Like when you tap save on your phone, where does that photo physically go?
Well, to answer that, we kind of have to look past the virtual space of apps and social media feeds. We need to recognize that the internet, it's not some invisible magic trick. The reality is a deeply physical infrastructure. We're talking about a massive, tangible web of billions of physical computers, routers, and incredibly long cable systems that quite literally wrap around the globe.
To really grasp this, we're going on a bit of an extreme journey today. We'll be covering the myth of the cloud, how data actually travels, the leap to space, and finally, who actually controls the internet. It's a trip that's going to take us from the bottom of the ocean down to microscopic data pulses and then all the way up to the stars.
So let's jump right into Section 1, the myth of the cloud, where we're uncovering the physical backbone of our connectivity.
Look, we've all been sold this marketing myth of a soft, floating, ethereal cloud, right? But the gritty reality is quite different. The cloud is actually grounded in steel and concrete. It's really just a massive series of interconnected wires and hubs located in these highly secure physical buildings that route data between different providers.
And connecting those buildings requires an absolutely epic journey. For most of us, the internet starts in what experts call the first and last mile. So your local Wi-Fi router or a nearby cell tower. But when your data needs to cross the globe, it literally dives underwater. It crosses the Atlantic, the Pacific, and Indian Oceans via physical undersea fiber optic cables. And get this, the glass fibers inside these massive ocean cables are astonishingly fragile. We're talking often no thicker than a single human hair.
Which leads us perfectly into Section 2, how data actually travels, and looking at the microscopic journey.
Because you have to wonder, how does a massive high-definition video squeeze through a glass wire the size of a hair? Well, the answer is that it doesn't travel all at once. Rather than sending one giant file, the internet uses this brilliant concept called packet switching. Imagine taking a letter, cutting it up into 100 tiny pieces, putting each piece in its own envelope with a to and from address, and then mailing them all separately. That is exactly what the internet does to your photos and emails to move them efficiently across the globe.
And this happens in a really crucial three-step sequence. Step 1, your file is chopped up into those packets with each one getting an address header. Step 2, it's routed using IP, or Internet Protocol, which basically acts as the rules of the road, telling the data exactly where to go. And then Step 3, TCP or Transmission Control Protocol comes in as the quality checker. If a packet gets lost along the way, TCP tells the server, hey, resend that piece, ensuring your file is reassembled perfectly and doesn't arrive scrambled.
Now, those tiny packets physically travel as binary bits, just simple ones and zeros. At its absolute core, our entire complex digital lives are transmitted via pulses of electricity in traditional copper wires or flashes of laser light shooting through those hair-thin fiber optics we talked about, or radio waves bouncing around in our wireless systems. It is literally just physics in action.
Okay, moving on to Section 3, the leap to space, from 5G to low Earth orbit. Let's shift our gaze upwards to see how this endless quest for faster connectivity is taking us completely off-planet.
Down here on Earth, we are constantly pushing the limits of radio waves with technologies like 5G. Now, 5G uses much higher frequency waves, so it can pack way more data into a single signal. But there's a catch. Because the frequency is so high, these waves are super easily blocked by trees, buildings, even heavy rain. So to compensate for that, we have to build a massive increase in physical antennas just to keep the signal strong. It creates this huge terrestrial bottleneck.
So to bypass that bottleneck, we look up. And the scale shock here is massive. Just compare traditional satellite internet with modern networks like Starlink. Traditional satellites sit way out in geostationary orbit, roughly 36,000 kilometers away. And that creates a very slow, very frustrating lag. But Starlink satellites, they orbit at just 500 kilometers. That incredibly close proximity reduces the signal delay by an amazing 70 times.
But honestly, it gets even cooler. Instead of just bouncing signals straight up and down back to Earth, these new low Earth orbit satellites use optical space lasers. Yeah, literally space lasers. Because there's no atmosphere to slow light down in the vacuum of space, these lasers shoot data directly from satellite to satellite. It completely bypasses all those terrestrial limitations we talked about, bringing high-speed internet to the most remote places on the planet. You could literally be standing at the North Pole or sailing right in the middle of the ocean.
And that brings us to our final part, Section 4. Who controls the internet? Looking at decentralization and the ultimate goal.
With all of these deep-sea cables, microscopic data packets, and space lasers constantly firing off, you kind of have to ask, who actually governs this sprawling mess? Well, it might surprise you, especially given how absolutely critical it is to our global society, but there is no single boss of the internet. It's a largely decentralized network of networks. There's no one CEO, there's no world government that has some master off switch. Instead, each individual network is just managed and maintained by its specific owner.
Of course, for all these independent networks to actually talk to each other without total chaos, there has to be some coordination. To keep everything functioning smoothly, we rely on organizations like ICANN. They basically act as a giant global phone book. They manage the names and numbers so that when you type in a website address, your computer knows exactly how to find the specific server on the complete other side of the world.
But you have to wonder, why keep building it? Like, what is the end goal of expanding this massive infrastructure, especially with these crazy new space-based networks? Well, the answer shifts pretty dramatically depending on who you ask. On one hand, a primary goal is bridging the digital divide, getting rural and underserved areas connected to the modern world. But for the companies actually launching these satellites, it's also acting as a massive financial engine. And this brings us to a truly mind-bending reality about the future of the internet. Building the ultimate global network isn't just about giving you faster Wi-Fi to stream videos. For companies like SpaceX, the revenue generated by their satellite internet service is explicitly designed as a financial engine to fund much, much more ambitious goals. We are talking specifically about funding the colonization of Mars. And that leads us perfectly to the end of our journey today. From fragile glass cables sitting at the very bottom of the ocean to lasers firing in the vacuum of space, the internet is this constantly evolving physical giant. Which leaves us with a final, slightly provocative thought to ponder. Is the ultimate purpose of connecting everyone on Earth simply a stepping stone to taking humanity to the stars? Well, I really hope this explainer changed how you look at the device in your hands right now. Keep questioning, keep learning, and I'll catch you on the next one.